Hello, today we're going to be working on lesson 2.2 in quantitative reasoning. And some prep skills are being able to read a table. So let me share my screen here with y'all. Reading information from a table. This is a table of age groups of people, and they're divided up by their gender. So males and females, smoking rates in Canada. So this age group says that in the age group of 12 to 19-year-olds, 8.3% of males smoke. Smoking is most prevalent in the 20 to 34 age group. You can see that's the highest for all people where it says total. Also, looking at tables based on time. So this one down here it starts at 1965, and it's the percentage of smokers overall in the US, and it goes all the way up to 2015. But when we put it in Desmos, we're going to say 1965 is our 0 year, because it says if we call 1965 0, then 1970 would be 5, because 1970 minus 1965 is 5. We will always give you a start year when we're talking about time, so that we have a way to scale our values. Choosing appropriate number lines is important as well. So let's move on. Page 139, we're all about a coordinated effort. So we've been talking about graphing, and we've used graphs in different ways. We've already started using Desmos. But Theodore Roosevelt, one of our presidents, said, believe you can and you're halfway there. And that is true. Believing in yourself, believing that you can learn this material. It doesn't mean it won't take hard work, but if you have a positive attitude and belief in yourself, you're going to go much further. So let's move on down here to the bottom. It says, one of the most common ways to measure the strength of the United States economy at any given time is the percentage of adults who are willing and able to work who don't have jobs. This is commonly known as the unemployment rate. The unemployment rate, so you know, is calculated by the percent of people that are willing to get a job, not based on people that just are not working. Okay. These tables display the average annual unemployment rate for the years 1993 to 2018. This is an example of time series data, which are quantitative data that have been collected in different points in time. So we have the first year here is 93 and goes all the way down. This goes 93 through 03, and then it wraps around to the table below that starts at 2004 through 2018. A time series graph displays values on the axis compared to equally spaced time intervals on the x-axis. And so it says, use the table to write a verbal description of trends in the unemployment rate over that 26-year period. So we started at 6.9%. It went down all the way through 2000, and then started to climb slightly, and then started to go back down again, and then really had a big jump here in 2008 to 2009. That was our economy collapse there. Went up and then has been going down again. So we could say between 1993 and 2018, the unemployment rate has varied from what it was as low as 4.0 here, it looks like here. Actually 3.9. It was actually the lowest in 2018, 2019, 2020 before COVID hit. So 3.9 up to, I think there was a 9.9, was there? Or 9.6. 9.6. So kind of summarizing what we saw. With enough effort, you were probably able to write a reasonable description, but because there's so much data in the table, spotting the trends isn't exactly a simple thing to do. Next, let's look at the sample data, the same data displayed in graphical form. So this is called a time series plot. So this is the same exact data that we just looked at. We said that it was declining to about 2000, went up slightly, went back down. 2008, this is when this all occurred, right? And then went slowly been declining after that. So you're going to use the graph to talk about some of the trends that you see that maybe you didn't see before on a prior page. Go ahead and take time to do that. Next, I would like to make sure that we're understanding pieces and parts of the graph. So without the numbers running along the bottom side of the graph and down the left side, we wouldn't be able to understand any of the information the graph provides. Those numbers provide a scale for the graph, and they're always crucial in drawing a graph. So you always need to have a scale. Each of the number lines that we write on the scale is called an axis. The plural of this word is called axes when you have more than one. So if we turn to page 141, we'll see here, it says based on figures from January to October 2019, the average unemployment rate for that year was expected to be about 3.7%. Add this information to the unemployment graph. So between about 2019, right here. So we would go to, just after 2019 started here, and we would go up to 3.7. So we can see that our scale always starts at 0. That's important and is labeled. So we call this our x-axis, and are the years. Time is usually always on the x-axis. And then this is our y-axis, and this is our percent unemployed. And our scaling starts at 0, like I said, and it goes from 2 to 4, so that 3 is about in here. So 3.7 would be estimated to be just between 3 and 4. Okay, so this is called a rectangular coordinate system. And we talk about that down here. And this is your basic rectangular coordinate system. Oh, I did not do a good job. And the x-axis is just like a number line, because that is 0. And so when we talk about the X and Y axis, so this is our X movement and this is our Y movement. So it's kind of like moving north, south, east, and west. We're moving left and right and up and down. And our coordinates, so we know where the point is. So up here, we have this coordinate of 2019, 3.7. Our coordinates tell us where we are, and we always go alphabetical X and then Y. So our coordinates from up here would be 2019, 3.7%. Okay. And then the points where the two axes meet is called the origin. And the origin is right there. The origin has coordinate 0, 0. So we always know where we're starting. So page 142 says, since we don't need to worry about negative years or negative unemployment, the graph we drew earlier only showed positive values along each axis, but there are plenty of examples of data when negative values make perfect sense. So a rectangular coordinate system is often set up like this. The process of locating information on a rectangular coordinate system, like the 3.7 unemployment rate in 2019, is called plotting points. Okay. So number 3 says, what are the coordinates of the origin in the rectangular coordinate system? They are 0, 0. X is 0, Y is 0. This is your lesson check answer. Look carefully at the numbers on each axis. What distance does each box on the grid represent along the x-axis? What about the y? So up here, it appears that it goes 1, 2, 3, 4. And that's our ideal if we can. So the x goes by ones. And the y, we have 1, 2, 3, 4, but it goes to 10. So I think we might have to count by twos. 2, 4, 6, 8, 10. Yep. So the y-axis goes by twos. And it's not always like that. It just depends on what makes sense for your data. So number 5 says, plot each of the following points on the rectangular coordinate system above. Label the coordinates of each point. So A is going to be 4, 0. So that means 4, 0, we're going to the X4, 1, 2, 3, 4. And Y is not going up or down. So that's going to be right here. And that's A, 4, 0. B is at 0, -8. And that means our X doesn't move left and right at all, but we just go down -8. So X is not moving at all, and we're going down -8. So -2, -4, -6, -8. So that is right here, and that's B. C is at a -3, -4. So we're moving left, -3, then down, -4. So we're going over by ones, 3, 1, 2, 3 to -3, but down by 2s to -4. So -2, -4. So C should be right there. Letter D says 2, 7. So I'm going to use left and right. So we're going right 2, and then we're going up 7. So we're going over 2, 1, 2, and then up 7. And 7 is an odd number. So we're going to go 2, 4, 6, and between 6 and 8 is 7. So it's going to be right about here is letter D. So let's move on to page 143. We're reading this temperature display, and it says, what temperature is this display monitoring? And we can't really tell. It's about right there where this red filling is, but we can't tell because there's no scale. And it says, explain why the thermometer is pretty much useless. There is no scale. So exactly what we just spoke about. Then it says, what are the coordinates of the point drawn on the graph? We don't have any idea, again, because there is no scale. So you can see by evidence on both of these that scaling is very, very, very important. So important features of a good graph. Every graph needs to be labeled on the X and the Y axis. We need to show our scaling. Okay. That's very important. So make sure you're reading through these. If there's certain points on a graph that are important for some reason, you should label the coordinates so that you know exactly where they are. Okay. Our next piece is going to be almost on page 144. Almost everyone is interested in gas prices. They can have a very real effect on a household budget. The data in the following table show the average price of a gallon of regular unleaded gas in the US in January of each year from 2006 to 2016. Right ordered pairs of the form the years after 2006, comma, the price per gallon. And now notice we did this for you. So 2006 is our 0 year here. Then 2007 is going to be 1 year after 2006. So then you can go down here and say 2015. If you take 2015 and subtract 2006, you're going to get year number 9. So we're going to make coordinate points here of the year, which is 0, comma, the gas price of $2.32, 1 and 2.27, 2 and 3.05, 3 and 1.79, 4 and 2.73, and so on. Now, down below, it says connect the points you plotted to draw a graph. So we would be plotting all these. But make sure we have our labels for our X and Y axis. So on the bottom, it's going to be years, and make sure you put year since 2006. And then this is going to be gas in dollars. Make sure that you also write your units. Okay, so for instance, 0 was at $2.32. So 0 year, we're going to go up in between the 2 and the 250, closer to the 250, and plot a point. And then year 1 is just slightly below that at $2.27. Year 2 is at 305. So we're going to year 2 and we're going straight up and it's going to be just above the 3. I'm going to let you keep working and I'll be right back. Okay, so this is what your graph should look like or thereabouts. So number 7 says, what was the highest price of gas, of January gas between 2006 and 2016? Is the answer based on the graph different? So it should be, I think 2007, my graph, or actually 2006, my graph, this should be the highest point. So 2000, so this would be when it was so year 6, when it was $3.40, which is 2012. And yes, it should be the highest point matches the coordinate point. It says, so number 8 says, when was gas most expensive? Again, you may have 2 slightly different answers. Well, gas is most expensive when it was $3.40. So 2012. When did gas prices stay relatively level from one year to the next? So 1 year to the next, I'd say is right around 2012 to 2013. It went down 5, actually 2013 to 2014 only went down 3 cents. So 2012 to 2013. Over what time spans were gas prices rising? So here is a rising. So that is 2007 to 2008. And then here's a huge jump, right? From 2009 to 2010. And then a little slight jump in these 3 years as well. 11 says, over what time spans was gas getting cheaper? So there's a big drop between 2008 and 2009. And then there was another drop between 2014 to 2015. What was the largest single price change in 1 year? So I would say visually, you're going to look here because that was the biggest change, and that was 2008 to 2009. And so 2008 was 305, and we subtract 2009, which was $1.79, and that gives us, it went down $1.26, which is awesome. And 13 says, explain why we didn't bother to include negative values along either axis. So time cannot be negative. Money cannot also be negative. So money and time cannot be negative. There are some other questions here, 14 through 18, that I will do on a second video.